So far, we have looked at the basic ideas behind the process of hypothesis testing. We've looked at the thinking, the basic jargon, all the different types of tests that can exist, and so on. But one thing that we have not looked at is very, very important and will occupy us for the next little while, and that's the idea of the individual statistical test that is used in each situation. So in order to have a look at that, first of all, let me clarify what a statistical test is. Well, statistical test is a mathematical process that takes us from the data to the p-value. Remember that the p-value is a certain probability based on or computed on the basis of the data collected. And so the question is, well, how do we go from the data to that probability value called the p-value? Well, this is something which involves, as you can tell, a fair amount of number crunching. It's usually done on computers and so on, and we're not, as usual, we're not going to look into those technical aspects of it. But instead, what we're going to do is we're going to look at some important features of each of these tests in order to understand how the test works, and more specifically, if in fact it was an appropriate choice in the situation for which it was used. Now, one thing to keep in mind is that there are many such tests. There are many procedures that allow us to go from data to the p-value, and each of them has a special name, and hopefully you will become familiar with some of those names. Not all of them, but some of the most common ones. Well, so because there are so many tests that in fact for all of them we could basically take some data and throw them through one of these tests, we have to be careful how we do it. Okay, so most tests can be applied to any set of data. So I could take any set of data you can give me, and I could run some kind of whatever test you want on it. The point is that the p-value that they produce is valid only if certain conditions are satisfied. If not, there is the typical situation of garbage in, garbage out. If you're throwing some data through a test procedure, a statistical test that is not suitable for those data, then what you come up with is some p-value which has absolutely no meaning. So what we're going to be doing is we're going to focus on how to decide if a test that is used in a certain situation was in fact appropriate for that situation. And then from there on, we're going to assume that the computational part, the number crunching part, was done correctly. That's usually not a big issue since it's handled by computer programs which have been checked and rechecked by experts many times, and we can rely on them. So, what makes a test valid? Well, I hope you'll be happy to know that there is only 4 features that we need to look at, that you need to look at. I'm going to list them first, and then I'm going to go through each one of them in turn to explain what these features are, what they mean, and what they're good for, and why they are the important ones. The first one is the purpose of a test. We're going to be looking at what is the test for. The second thing is the statistics, both the statistics that the test uses and the statistics it produces. Thirdly is the requirements of the test. What does the test expect in order to work properly? And fourth, robustness. This is a strange word. Probably you have heard it before, but in other contexts, we'll see what it means in terms of statistics. Now, notice one thing. If you look at those 4 initials of those 4 words, purpose, statistics, requirements, and robustness, and you list them in reverse order, you come up with an acronym that probably you're very familiar with, and especially if you have already started planning for your retirement. So you may want to use this as a little bit of a mnemonic if you use mnemonics. Okay. But the important thing is, what do these 4 words mean in the context of statistical testing, and how do we check that in fact they are taken care of correctly? Oh, by the way, in case you wonder why I didn't put those 4 words in the reverse order, well, because the order I gave you is the one in which you really should be checking them, because each one is more general, more basic than the other. Okay, so we first want to look at the purpose, then the statistics, then requirements, then the robustness.